Hi, my name is Eren Kerimoğlu, and I'm a second year student at Bilkent University. My department is computer science. Today, I'm going to talk about my project, determination of the period of a simple pendulum. The main goal of my experiment is to explore how the period of a pendulum, the time it takes to complete one full swing, depends on the length of the string it's hanging from. I also wanted to test whether the mass of the bob affects the period, which theoretically it shouldn't. To do this, I used strings of 5 different lengths and 2 different bobs with small but different masses, 5 grams and 10 grams. For each trial, I pulled the pendulum to a small angle, less than 15 degrees, to make sure the simple harmonic motion approximation was valid. Then I measured the time for 10 full oscillations, repeated it for each length and each bob, and calculated the period. After plotting period squared, t squared, versus the length, I was able to calculate the experimental value of the gravity using the well-known formula. Alright, now I'm going to show you some pictures from our experiment to help you visualize how we conducted the experiment. This is our first bob, which is 5 grams, and this is our second bob, which is 10 grams. Here, a sample string. I guess this is 20 centimeters, and with our first bob. This is exactly how we calculated the angle that the pendulum makes with the normal. This is another sample length of string with our second bob. This is a picture from our experiment. This is me, this is my friend, using the stopwatch on his phone. This is 45 centimeters length of string because that's the maximum we could do. You can see how close the bob is to the ground. This is another picture from our experiment. And here are some videos to help you visualize the experiment. This is me releasing the mass and calculating how much time did it take for 5 oscillations. And we also did this calculation for 10 oscillations and take the average. This is again me from different angle with a different length of string, and my friend is calculating the time of period here again. Now I'm going to share with you our resulting graphs and tables. First thing first, let's see our tables first. There are 2 different tables, and the different variable between 2 tables is the mass. Here 5 gram mass and here 10 gram mass. There are time for 10 oscillations period and the experimental G we found. There are similarities between 2 tables if you carefully look. For some takes, for some trials, the gravity is the same, but as you can see, for some trials, it's different. This cause of our errors. There are the graphs. Okay, let me show you the first graph. This is the linear graph because it's period squared versus length of string to calculate the gravity here with this formula. As you can see, there's a difference between 10 gram mass and the 5 gram mass trials. And this the other version of our graphs. This experimental G and the length of string. Okay, this is our expected G, 9.8, and this is the G we found for each trial. The yellow is the average, and green and blue are the 5 and 10 gram masses. As you can see, there's a difference with the experimental G and the expected G, and this is caused because of the errors, which I will explain at the end. My calculated values of G were close to the theoretical value of G, which is 9.8, with a small average error, like 9%. Also, my result clearly confirmed that mass had no effect on the period, matching the theory. Some minor errors came from the reaction time when using the stopwatch, possible angle measurements, inequalities, and slight air resistance, but overall the experiment matched expectations. This project helped me better understand the physics of pendulum motion and improved my skills in conducting careful systematic measurements and analyzing real-world data. Thank you for watching.